In this section of coordinate geometry, we are going to look at what it means for two lines to be perpendicular to each other, and what this tells us about their gradients. Now we have here two lines, L1 and L2, and we're going to begin by finding their gradients. So for L1, we can see that the change in x is equal to 4, and we can see that the change in y is equal to 3. For L2, the change in x is 3, and the change in y is negative 4. So this tells us that the gradient of L1 is equal to 3 over 4. And the gradient of L2 is negative 4 over 3. Now from that, we can see that the gradients are connected somehow. If we were to multiply them together, so if we multiply these two together, we see that we get 3/4 times negative 4/3, which is equal to negative 1. And in fact, this is true of all perpendicular gradients. So we have that if two lines are perpendicular to each other, then the product of their gradients will be negative 1. So if we know one gradient, then we know to find the perpendicular gradient, we need to find the negative reciprocal of that. So we want to put negative 1 over that gradient, and this will give us the other one. Now let's take a look at some examples. So we have a line, and we want to show that it's perpendicular to another line. So all we need to do is find the gradients of these two lines, and then see what the product of them is. So, one of our gradients is quite clearly equal to 3. The other one, we need to rearrange the equation first. So we have x plus 3y minus 3 is equal to 0. So let's move these to the other side. 3y is equal to negative x plus 3. We then divide by 3. We get negative 1/3 x plus 1. So now we know our other gradient is equal to negative 1/3. So if we multiply them together, we'll get 3 times negative 1/3. So we can see that this makes negative 1. For question 10, we want a line that passes through a point and is perpendicular to this other line. So, the gradient of our given line is 2, and we want a gradient that is perpendicular to that. So then m2 times 2 is going to equal negative 1, so m2 is equal to a negative 1/2. So that is the gradient of our line. We know that it passes through the point 3, negative 1, so we can just use our formula for the equation of a line. Y minus y1 is equal to m x minus x1. So then we substitute in our values, is equal to minus 1/2 x minus 3, and at this point we can stop, because the question has not asked us to put the equation in any particular form. So, if you're happy with that, then please take a look at exercise please take a look at exercise 5e. Or if you're feeling very confident, take a look at the mixed exercise, which will test you on any part of this chapter.